All right, here are solutions for the first quiz for Math 211. A couple of different problems on this quiz. This first one is kind of this cricket problem. You got this cricket, he's trying to jump out of a well, and good news is he can jump 5 feet at a time, so that seems like it'll help him get out of the well, but unfortunately it's a slippery well. Every time he jumps up 5 feet, he then slips down 3 feet. So you might think about it like, all right, he goes up 5 and then he goes down 3, so each time he makes up 2 feet. So take 101 and divide it by 2 or something like that. The problem with doing that is he's going to stop slipping when he gets to the top. So really what you want to do is think about how many jumps it'll take him to first reach this height of 101. It's not like once he gets to 101, he'll slip back down to 98. He'll be done once he gets to this 101. So sort of how many jumps for his maximum height to be 101, I guess you could think about it. Lots of different strategies. You could use algebra. Maybe let x represent the number of times he has jumped, and then the height as a function of x. Maybe you could figure that out, the highest point that he's ever reached. Or a picture may help. So to kind of realize these at 5 and then back, maybe a number line type thing. Maybe I'll even write that number line, question mark. What I'm going to do is going to be slightly different than that. I mean, it's all basically the same idea. What I'm going to do, I'm going to figure out when the cricket slips to 96 feet. Wait, what are you talking about? Okay, when I say slips, I mean his height changes every time he jumps and then again every time he slips. And so after the first time he slips, his height is at 2 feet because he goes up to 5 and then down 3 to 2. And after the second time he slips, his height is at 4 feet. Maybe I should make a little chart to keep track. Slip, number, and then height. So the first time he slips, I claim that he will end up at a height of 2. That's because he went up to 5 and down to 3. The second time he slips, his height will be 4. The third time he slips, his height will be 6. And maybe you can see a little pattern. What I'm trying to do is figure out when he will slip to 96 feet. Well, following this pattern, the number on this side is always half of the number on this side. So I could just take 96 and cut it in half and get 48. So I'm going to figure out when the cricket slips to 96 feet. That's what I do over here. It's after 48 jumps. The nice thing about being at 96 feet, if you can jump 5 feet at a time, is one more jump will get you up to the top, 101 feet. So after 48 jumps and the subsequent slips, he's up at 96 feet. One more jump gets him out of the top. 48 plus 1 is 49 jumps. And after 49 jumps, this cricket will be up out of the well. That's the answer to the first question. Unfortunately, I don't know that I really left room for an answer to the second question. But maybe I can slide it in somewhere. Maybe I could throw it up at the top or down at the bottom. Yeah, let's do it down at the bottom. This is 1, part B, over here on this side. So part B says, if he has enough energy to jump 200 times, what is the deepest well that he can get out of? So that's a little bit tricky. The way I like to think about it is similar to what I did up here. After 199 jumps and slips, he would be at, let's see, if I had 199 here, the number on this side is exactly twice that. He's at 199 times 2. 200 times 2 is 400. So 1 less than 200 times 2 is 2 less than 400, in other words, 398. So after 199 jumps and slips, he's at 398 feet. One more jump. 5, foot jump would get him out of a 398 plus 5. In other words, a 403 foot well. So that will be my answer. Is that for part B, he could get out a 403 foot well in this circumstance. Okay, question 2. Question 2 says, John is twice as old. Where's my little cursor? There it is. John is twice as old as his friend Peter. Peter is 5 years older than Alice. In 5 years, John will be 3 times as old as Alice. How old is Peter now? I think the easiest way to do part 2 is to use algebra. Although I guess you could get there with guess and check as well. If you were to use algebra, what we could do is make a little table here. So maybe age, and then you'll note that in here it talks about how old they'll be in 5 years. So age in 5 years. And I guess I need one more column for the person. So I have John, Peter, and Alice. But the question is asking me how old is Peter. So that's kind of a hint that for Peter, it might benefit me to call his age P, or make that my variable because that's what I'm trying to solve for. And so if he's P right now in 5 years, he will be P plus 5 years old. What about John? Well, John is twice as old as his friend Peter. If Peter is P, John would be 2P. And in 5 years, he would no longer be 2P. He would be 5 more than twice what P is. And then lastly, we got Alice. And what do we know about Alice? Peter is 5 years older than Alice. So that's a little bit tricky. If Peter is 5 years older than Alice, then what that means is Alice is 5 years younger than Peter. So Alice would be the same age as Peter, except you got to take away 5 right here. So Alice's age is P minus 5. So in 5 years, it would be P minus 5 plus 5, aka just P right here. I think with this information, we'll be able to set up an equation and solve. In 5 years, the one piece of information I haven't used yet is that in 5 years, John will be 3 times as old as Alice. So in 5 years, John is this age, 2P plus 5. This is John's age in 5 years. In 5 years, John will be 3 times as old as Alice. So John will be equal to 3 times what Alice is. So this P goes right here, and this 2P plus 5 goes over here. And then if I solve this equation, I could subtract 2P from both sides of the equation to get that 5 is equal to P. Therefore, Peter's age is 5. You can go through and check this. If Peter is 5, then John is 10. Alice is 0. Odd, but okay. I guess just born. Can you be 0? Yeah, you can be 0. You're a newborn. Fine. Alice is a newborn. And I think we can go through and check all these things and make sure they work out. But I'm not going to check. I'm going to end this video here.